Now, this is an example of an equation with variables on both sides. I have to move one of the two variable terms to the other side. I either have to add the 2x or add the x. Doesn't matter which one. So let's say I'm going to move this one, as long as I do it to both sides. Negative x plus 2x is x. Then I subtract 200. What do I get? If I subtract this 200 over here. Forty brown-eyed people would have to leave in order to create a room that has 50% people that have brown eyes. All right, and you can check this, plug it back in. 120 minus 40 is 80. 200 minus 40 is 160. 80 out of 160 is a half. Does that problem make sense? Okay, so the new thing we're adding, and I'm only going to show you 3 examples, so it's not going to take a super long time, is I want to be able to take those inequalities that we've done. We did the basic ones of like, x is greater than 4, x is less than negative 2, and we've done that. But I want to be able to take inequalities that have more than just x in them and be able to solve them. Here's the good news. All of the rules we use for equations still work. They're the same. I can still add to both sides. I can still subtract from both sides. I can still multiply both sides. I can still divide both sides. I can still distribute. All those things still work. So I don't have to relearn any of those rules. They're the same. Here is the only additional rule. If I happen to multiply or divide by a negative number, the inequality sign flips. That's it. If that doesn't happen in the problem, we won't change anything. It'll just be exactly how you would do it otherwise. But if I multiply or divide by negative, in other words, if I say, hey, what did I do in this step? And I put, I divided by negative 3. If I say the word divided by negative, you flip the sign around. I multiply by negative 4. Multiply by negative, flip the sign around. That's it. All the other rules stay exactly the same. That's why we don't have to spend a huge amount of time going over the rules for this, because they're the same rules. They don't change. So let's just look at an example so you can see how this works. I want to solve 3x minus 1 is greater than 8. If I had 3x minus 1 equals 8, what's the first thing I would do? What's the first thing I have to do to solve this problem? Equals 8.
You have to like solve it.
Right?
Yeah, like do the other one.
Well, yes, you can solve it.
Good,
But what's the first step you would do?
You would add 1 to the 8.
I would add 1. Right? Get rid of this minus 1. I'm still going to do that. Now, did I multiply or divide by a negative?
No.
No. So the sign just stays put. It just drops down. Now what?
You do divide by 3.
Divide by 3. I'm still going to do that. Did I multiply or divide by a negative? No, I divided by positive 3. Sign stays the same. So x is greater than 3. That's what we call algebraic notation. If I asked you, hey, give this to me in interval notation, I would write the number first, so 3 is important. Now, for what I have there, is x bigger or smaller than 3?
Bigger.
Bigger. X greater. This thing always points to the smaller one. So it's bigger than 3. So since it's bigger, comma goes on the bigger side. If I don't stop to the right, that's what infinity means. Infinity means don't stop to the right. automatically, parentheses by infinity, every time. That's never gonna change. Is 3 okay?
It's a wrap with a wrap with a parentheses.
Is 3 good?
Yeah, but it's not
No.
equal to.
Yeah, it's not equal to, exactly. So if it's not equal to, you get a parentheses. That would be the interval notation for that. So if I give you a question that says, give me the answer in interval notation, that's what you would write. Parentheses 3, comma, infinity. Parentheses. Do you see kind of how that changes back and forth between x is greater than 3 and that? Now, sometimes if it doesn't say interval notation, that's perfectly fine. You can leave it like that if it doesn't say interval notation. But if it does say interval notation, you keep that, or it won't. It's like with most other things. If it says it, do it. If it doesn't, then solve it however you want. Okay, does that make sense? If you know how to solve that equation, you know how to solve the inequality. The only thing that changed there was the answer is a range, it's not a number. That's it. So let's use the same concept to solve this one. I have 4 minus 5x is greater than or equal to 19. So just like with a normal equation, I'm going to get rid of the number first. The only way to get rid of a positive 4 is to subtract 4. Sign stays put because I didn't multiply or divide by a negative. Here's where the new rule kicks in. What would I have to do now? I have to divide by -5.
And then your sign flips to
Yes.
less than. No.
So now, when you do the outside parts, they're normal. So that's still going to cancel to x. 5 divided by -5, or sorry, 15 divided by -5 is still -3. That doesn't change. You don't do anything weird with the outside. But since I put divide by negative, the sign flips. That's the application of the new rule. That's the only new thing that happens. Is hey, that just has to flip around. So this would be my algebraic answer. If I do an interval, I know -3 is important. Which side is x on? Is it less than, is it smaller or bigger?
It's smaller.
Yeah. X is smaller, so it goes on this side. If I don't stop to the left, that's negative infinity. You can always think about it. That's exactly what
Wouldn't
infinity is.
negative infinity be less than 3? -3.
Yeah.
No.
That's why I thought the left.
So it's less.
Yes, on the left side, it's gonna be less than.
It has to be smaller. Now, this should take no thought. That's a parentheses. -3 has an equals, so the -3 is going to have a bracket. So when you're dealing with the infinities, just keep that in mind. They literally just mean positive infinity is right forever, or don't stop to the right. Negative infinity is left forever, or don't stop left. So if I can go to the left forever, that's negative infinity.
Could negative infinity also be more than -3?
No,
Absolute value.
But it
that's a
would,
completely different issue.
if it's negative, then it could also be -4 and -2.
Negative infinity means left forever. That's what it means. It means keep going to the left forever. So this is telling you start at -3 and go left forever. Does that make sense? I see the confusion. I know what you're trying to say. Like negative infinity doesn't mean negative, all negatives. That's not what it means. It means all the way to the left forever. I see what you're saying. I get why that's confusing. Okay, do those two make sense? Try to get both of those answers.
Yeah.
This is if it says interval notation. This is if it doesn't say anything. Even if it's interval notation. And then the third one is going to look a little weird, but it's not going to be anything crazy, even though it looks like it is. I have -3 is less than -2x plus 3, which is less than or equal to 9. So we're just going to go where the variable is, -2x plus 3, and go, if this was a normal equation, I would subtract that 3. If there's 3 parts, I'm just gonna subtract it from all three parts. That's the only thing that changes in those. Inequalities have that special thing where they can have three parts, where an equation can only have two. But it's the same thing, just subtract 3 from all of it. That's -6. That's -2x. That's +6. The parts operate normally. And since I didn't divide by a negative or multiply by a negative, the signs just fall down and stay the same. Now, I would say, I need to divide by that -2, and I'm going to do that everywhere. I divided by -2. So when I do this, that's still 3, that's still -3, that's still x, but these signs are going to flip around. Do you see what I mean by the parts operate normally? You just divide them normally like you would. Right? -6 divided by -2 is +3. 6 divided by -2 is -3. -2's will cancel there, you'll just get x. But the sign flips around because I put the negative on the bottom. Now, if I would, this would be fine for algebraic, but if I say interval, intervals have to be in number line order, so I'm going to put -3 to 3. And I know I can put the comma there because that's where x is. X is sandwiched between them. So I put it in the middle there. -3 gets what? What do I put next to -3?
Yeah.
Okay. So I put a bracket because the -3 has 3 does not. So in other words, everything between 3 and -3, including -3, but not including 3. Okay, does that process make sense? Okay, the whole backside are practice problems. I want to give you more time than usual to practice on them. So go ahead and work on those the rest of the time. If you're struggling with any of it, you need help getting started, if you need any help whatsoever, let me know. I'm
How
coming
is
around.
70 degrees outside?
Huh? It's in here. They can't measure outside.
No,
It's
you-
on the wall. It only measures.
Oh.
Huh? I forgot to tell the other class, but when we're using this time to practice, I would make sure that I am utilizing it the week before break. We will be taking an end of semester assessment that's going to count as a chunkier grade. So